Ladies and gentlemen, in today's class we are going to solve quadratic functions using the quadratic formula, which is going to be this, and I'm going to explain this in just a moment. But if you recall, solving quadratic functions, what we're looking for is we're looking for the x-intercept. I'm sorry, let me move this over. We're looking for the x-intercept, which is the exact same thing as a 0, which is the exact same thing as a root. So we're looking for the x-intercept, the 0, the root. We're looking for something with the coordinates, an y-coordinate of 0, and we're looking for the value of the x-coordinate. So we're looking for x equals what number? And we know how to do this graphically because we can go second calc 0 in the calculator to find our 0. We can solve this using factored form, x minus 3, x plus 2. We set each one equal to 0. And we solve. X equals 3, subtract 2, that equals 0. X equals negative 2. We did graphically, we've done the past couple of weeks. We solved factored form for x. We did that last week. But now we want to take a look at quadratic formula because there are going to be instances where we're not going to have a factored form, where we're using factor form like this isn't going to work. Because there are decimals instead of whole numbers. And you know, what happens if you're stranded on a desert island and you don't have your graphing calculator with you? How in the world are you going to solve a quadratic formula graphically when you don't have your calculator? So it's good for us to know how to do this algebraically, just in case we ever get stranded on a desert island and we need to solve a quadratic formula. So if you take a look at what we got here, we've got negative b plus or minus b squared minus 4 times a times c, all over 2 times a. Well, if you look at all these variables that we have, these coefficients, what form of the equation do we need in order to use quadratic formula? A and B and C. What form is that? You know what? That's standard form. F of x equals ax squared plus bx plus c. So in order for us to use quadratic formula, we need to have standard form. So that's good because we know how to get standard form either using the box method when factored form, or if we're using vertex form, we can get back to standard form now. So that's really good. And if you take a look at this, it's all pretty straightforward. We take our numbers and we put them in the correct place. The thing that might be a little weird is that, see this symbol right here, this positive and this negative. What does this mean, this positive and this negative, this addition and subtraction both at the same time? We've never seen this before, but let me explain what this means. Let me move my piece of paper up a little bit. And we need to talk about what a square root is just very briefly. Let me just remind you. So if I square something, I take 4 times 4, and that equals 16. Well, if I take 4 squared, that also equals 16. Now, amazingly enough, if I take negative 4 times negative 4, you know what that equals? Negative and a negative make it a positive. It equals 16. And if I take negative 4 squared, that equals 16. Let's think about this for a moment, because if I take the square root of 16, what do I get? Well, what two numbers multiply to get you 16? 4. So if I take the square root of 16, that's the same thing as unsquaring something. That equals 4. But hold on a minute. That's not making sense because a negative 4 squared also equals 16. How come I can't get a negative out of this? Well, you can. And that's something that we need to realize that when we're taking the square root of something, is that this square root of 16 equals negative 4 is true. And so is the square root of 16 equals 4. Both of these statements are true. Both of these answers are correct. If you take the square root of 16, it is mathematically possible the square root of 16 equals positive 4, and it equals negative 4. So that's what this symbol right here means. It means that when we take the square root of all of this, it's either the positive value or the negative value of whatever the square root of this value is. So there's going to be a negative value and a positive value because two negatives multiplied by itself and two positives multiplied itself can equal the same value. And when we take the square root of that, it's either going to be a positive value or a negative value. It can be both. So what this means is we need to practice setting this up, and let's do an example problem. Let me give you the equation f of x equals 1x squared plus 2x minus 3. And what we want to do is we want to create a laundry list. We're going to call this the laundry list. I've got A, B, and C, and I've got some different parts here. So I need to know A, B, C. I need to know what negative B is. I need to know what B squared is. And I need to know what 4 times AC is. 4 times A times C equals what? So once we get our laundry list, we're just going to fill in the values. 1, this is B coefficient is 2, C coefficient is negative 3. Negative B would be negative 2. B squared, 2 times 2 is 4. This is 4 times A is 1 times C is negative 3. You see why I use parentheses to make sure that we multiply this negative value. 4 times 1 is 4. 4 times negative 3 equals negative 12. Now, I can take this information and I can substitute these values into the quadratic formula. And I can say x equals negative b is negative 2 plus or minus the square root of b squared minus negative 12 all over 2 times a, and a was 1, so 2 times 1. And we can simplify this, and you can do this in your calculator if you'd like. Negative 2 plus or minus. A negative and a negative make a positive, so this is the square root of 16 over 2 times 1 is 2. And this equals, square root of 16 is 4, so negative 2 plus or minus 4 over 2. And then we're going to split this up at this point, equals negative 2 plus 4 over 2, or, because there's two possibilities here, negative 2 minus 4 over 2. Negative 2 plus 4 is 2 over 2. Or this can equal negative 2 minus 4 is negative 6 over 2. 2 over 2 is 1. Negative 6 divided by 2 is negative 3. So my roots, x equals negative 1 or negative 3. And this we've solved quadratic form. We've solved the quadratic function. We've solved the quadratic function using the quadratic formula. And our answer is x equals 1 or x equals 3. Let me do another example. Let me do it, let's see, I need to get a new piece of paper here as I'm running out of space. Let me do it right here on this piece of graph paper. The second example is going to be f of x equals negative 2 x squared minus 20 x minus 50. Now let's make our laundry list. A, B, C, what are those equal? We need negative b, we need b squared, and we need 4 times a times c. A is negative 2, b is negative 20, c equals negative 50. Negative b, negative and a negative, so it would be a positive 20. B squared is negative 20 squared. Negative 20 times negative 20. Negative and a negative is a positive. 20 times 20 is 400. So we're going to put 400. 4AC, 4 times A is negative 2 times C, which is negative 50. So that equals 4 times negative 2 is negative 8 times negative 50. And that's going to equal negative and a negative is a positive. And 8 times 50 is 400. Oh, that's interesting, 400 and 400. Let's see what happens there. All right, so we're going to use our quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let's start substituting values. Negative b, we said was, let me pull this down, 20 plus or minus square root of b squared was 400 minus 4ac, 400, all over 2 times, let's say a was negative 2, 2 times negative 2 is negative 4. Okay, well, let's see what we got. 400 minus 400 is 0, so that's 20 plus or minus the square root of 0, all over the square root of 4. Now, what two numbers multiply together to get you 0? Square root of 0 is going to be 0. Yeah. So 20 over negative 4. So there's no more options here. There are not two options because this went away. All this equals 0, so there's nothing to add or subtract to the 20. And therefore, 20 divided by negative 4 is negative 5. So this particular example, this only touches the x-axis once at negative 5. Where the previous example, this one touched x twice at negative 1, at positive 1, and at negative 3. So here we have two roots. Here we have one x-intercept, and this is how we're going to do our problems today. We've got 5 problems that we're going to work out together. I'm going to give you standard form. You're going to make a laundry list. You're going to substitute values. You're more than welcome to use your calculator. And then you need to tell me, finally, what is the solution? X equals what value? The x-coordinate of the x-intercept.